Okay, good morning, everybody. So just before we get to our first question, so math 6. Just some background content for the questions today. So the first principles definition of a derivative of a function f of x at point x can be determined using the following limit. So f prime at x is equal to the limit as h approaches 0 of f at x plus h minus f at x all over h, or written another way is the limit as u approaches x of f at u minus f at x all over u minus x. Okay. And this is the slope of the tangent line of f at point x, f at x. One other note, if the function is not differentiable at x equals a, then the limit does not exist. Also, if the function is discontinuous at this point, then the derivative doesn't exist. This is all stuff from your lectures the last week or so. So just that's what we're going to use to solve our questions today. We will start with the question from the lab that is already solved for you. So that is find the value of the derivative at x equals 1, or explain why the derivative doesn't exist. And f at x is equal to x squared plus 4, or x is greater than 1, and 3x plus 2 for x is less than or equal to 1. So go ahead and get started on that. And then we will go through it together in a minute or so. The solution, at least the mathematical part, not the written part for that, is in the lab document. Yeah. Okay, so that was just a good clarification here for this here, saying that the limit does not exist is referring to this limit. The limit as x approaches some number of f at x can exist. But this limit won't exist. Okay, so I've added a graph of this function just so we can see what's going on. But let's go ahead and go through it. So for f at x, f at 1 is equal to 5. So let's do first from the right. So the limit as h approaches 0 from the positive of f at 1 plus h minus f at 1 all over h is equal to the limit as h approaches 0 from the positive of, if we sub this in here, it's x squared plus 4, because that's when x is greater than 1. So we have 1 plus h squared plus 4 minus 5 all over h equals the limit as h approaches 0 from the positive. This will be 1 squared, so that's just 1 plus 2h plus h squared plus 4 minus 5 all over h equals, actually, he uses the difference of squares. Never mind, sorry about that. So if we evaluate this limit as h approaches 0 from the positive of, if we evaluate this, this would be 1 plus h squared plus 1. Both of these terms are squared, so we can use difference of squares. So it would be 1 plus h plus 1, 1 plus h minus 1. And over h equals the limit as h approaches 0 from the positive. Here, the 1s would cross out, so this just becomes h times h plus 2 all over h. These h's eliminate. Limit as h approaches 0 from the positive of just now h plus 2. And because we no longer have that division by 0, we can just sub in the value for h. And so that gets us 0 plus 2, which equals 2. So that is from the right. And now we will do one from the left. Let me freeze that. And so now the limit as h approaches 0 from the negative. Yeah, there we go. Of f at 1 plus h minus f at 1 is equal to the limit as h approaches 0 from the negative of, and we're using 3x plus 2 because we're coming from the negative. So 3, 1 plus h plus 2 minus 5 all over h equals limit as h approaches 0 from the negative of 3 plus 3h plus 2 minus 5 all over h. Of course, these different, these constants here, 3 plus 2 is 5, minus 5 is 0, so they cancel each other out. So we get the limit as h approaches 0 from the negative of 3h over h. Now we can eliminate these. And we can sub in now h because there's no division by 0, but there's no h there, so subbing it in just makes it the constant 3. And so what we have here is the limit from the left is 3, as we just calculated, and the limit from the right is 2. So therefore, since the left-hand side and right-hand side, since the left-hand limit does not equal the right hand limit, the limit does not exist, which means the derivative of f at x equals 1 is undefined. Are there any questions on that? Yeah. So this is for question F. So the one at the end where the solutions provided. So it's x squared plus 4. For when it's greater than 1, it's x squared plus 4. When it's less than or equal to 1, it's 3x plus 2. Yeah, if you downloaded the lab earlier in the week, if he had it up there, it did change since then. I had to change all the solutions. So, but we will get to that example. Any other questions? No? Okay. It's frozen. So go on to the first real question now that doesn't have a solution there. Okay. So exercise 1. Okay, so once again, it's the very similar thing, so I'm not going to rewrite out that line. But now do the same thing for at x equals 1 for a at x is equal to the piecewise function x squared plus 4, 2x plus 3. This is when x is greater than 1, and this is when x is less than 1. So go ahead and start that and talk amongst yourselves. If you have any questions, throw your hand up. I'm going to draw the graph, and then I'll come around and answer any questions, and then we'll go through it together. So let's do exercise 1. So I've drawn a graph here of a to the x. And so there is no definition for a to the x at 1. So there is a hole here. For values greater than 1, it follows along this curve, and less than 1, this line. So from our definition here, we know that if it's discontinuous at our point, then the derivative doesn't exist. So right off the bat, we could just say a to the x is discontinuous at x equals 1, and therefore the derivative does not exist. So you could do that. That would be a valid explanation. It is discontinuous. We have that theorem from notes. Let's pretend we didn't notice that, or we didn't see it, or whatever else, and see what would happen when we went through and did it. So, okay, so first take the right hand limit. Since it is the right hand limit, we're going to use x squared plus 4. And x equals 1. Okay, so a prime at 1 is equal to the limit as h approaches 0 from the positive of a1 plus h minus a at 1 all over h. And immediately once we get to this point, we say, okay, we need to find what a at 1 is. Well, if we look at the graph, it's undefined at a at 1. It also is not defined here within the piecewise function. So since we have nothing to sub in there, we aren't able to compute this. This limit doesn't exist. This limit does not exist, and is not differentiable at x equals 1. And of course, since we already have one side of the limits not existing, we already know the entire limit also doesn't exist. But just for completion, we'll still try it with the left hand, but the same thing's going to happen. Left hand using 2x plus 3 and x equals 1. A prime at 1 is equal to the limit as h approaches 0 from the negative of a to the 1 plus h minus a to the 1 all over h. Same thing, because we have nothing to sub in for this value, the limit does not exist and is not differentiable at x equals 1. So, and that's another thing to remember. Remember that just 1 second on the question. Remember that the derivative here is the slope of the tangent line to this curve at this point. Another way to say that is the tangent line is the line that touches the function at a single point. It obviously can't touch a function that is not defined at that point. So that is another way to think about it. But either way, derivative does not exist. It's not differentiable there. And your question? Mhm. Yeah. So in the previous question, which was F, which is x squared plus 4 when x is greater than 1, 3x plus 2 when x is less than or equal to 1, it is defined at 1. Yep. Yep. So if I look at this function and I'm coming in from the right, I'm only considering this equation. So I will use that equation when I'm calculating the limit. When I'm coming in from the left, all I'm considering is this equation. So I use this part of the piecewise function when I'm coming from the left. Yeah. Right. So it is defined at this point, and it happens to touch as it's coming into here. Basically, this is saying, so the limit here doesn't, or sorry, the derivative here doesn't exist because it would have to both be 3 and 2 at the same time. It can't be. So, and the reason for that is because the slope of this line and the slope of this line are not agreed at this point. If they were agreed, then it would exist. Okay. Okay, so are there any other questions? Oh, yeah. Yeah. Yeah, so let's say we have there's the examples from the notes. So here, this would be f at x is equal to, it will be x for x is greater than 0, negative x for x is less than, let's just add the equal to 0 there. Okay? So here, if we were to find the limit of f at x as x approaches 0 from the positive, it would be 0. And if we found the limit of f at x as x approaches 0 from the negative, it would be 0. So the limits on the actual function exist. We're good with that. Now what we're saying is, let me just draw one more visual. So let's say we have so now we're finding the tangent line. Okay, and so that's why, so we have f at x here, and we're saying, let's say this is 1. What is f prime at 1? Okay, and so what we're basically doing is we're saying, okay, one of the ways to find f prime at 1 is to use this equation. F prime, we're just going to say at x, is equal to the limit as h approaches 0 of f at x plus h minus f at x all over h. So we're finding f prime at x. And one of the ways we can do that is use this limit. So when I'm talking about the limit not existing, is I'm saying this limit doesn't exist. I'm not talking about these limits. So if you were to, in that example, let's say we have a hole and we have a function that's going like this. If we were to want to find any secant line, forget the tangent line, of, let's say this is the point 1, 2, and this is the point 2, 4, then this would be your secant line, right? So basically we say, okay, what is f at 4 minus, f at 2 minus f at 4 all over 2 minus 1, our rise over our run, right? F at 2, or sorry, f at, what am I doing? Okay, this is our f at 2 minus f at 1, right? So our rise, so from here minus this to this minus this. F at 1 is not defined. So this is unknown. So we could do this. So this is 4 minus question mark over 1. Right? There is no slope of the secant line for this function, right? Because it's not defined there. I could sub in 1, 2 because I know where that hole is, but it's not actually defined at that hole. Yeah. Okay, cool. You're welcome. Okay, let's get the next question up here. Okay. Exercise 2. So, same thing, at x equals 1, what is c prime at 1? And c at x is equal to x squared plus 4 when x is greater than 1. It is equal to 7 at x equals 1. And it is 2x plus 3 at x is less than 1. So go ahead and get started on that. I will draw a plot of this function and then come around and answer any questions before we go through it together. Yeah. Okay, I'll come there as soon as I'm done drawing. Okay. So let's go ahead and go through this. Okay, so we once again see that it's obviously discontinuous at the point x equals 1. So we could just stop there and say, okay, the derivative doesn't exist, but we're not going to do that. We're going to go through the equations. So c prime at 1 is equal to the limit as h approaches 0 from the positive of f at 1 plus h minus f at 1 all over h. Equals, we're coming from the right, so we're going to be using x squared plus 4. So that will be 1 plus h squared plus 4 minus f at 1, which is 7, minus 7 all over h equals, oh, and this is the limit as h approaches 0 from the positive. So then we get the limit as h approaches 0 from the positive of 1 squared is 1 plus 2h plus h squared plus 4 minus 7 all over h, which is equal to limit as h approaches 0 from the positive of h squared plus 2h minus 2 over h. And so if we look at this, there's no easy way, well, there's no way to remove this h. But if we were to sub in at this point and we were to get 0 and 0 minus 2, so a negative at the top, and then at the bottom we're approaching 0 from the positive. So we know from our rules of limits that this is equal to negative infinity. And so that is our limit from the right. And then we have, once again, now from the left, c prime at 1 equals the limit as h approaches 0 from the negative of f at 1 plus h minus f at 1 over h. We're coming from the right, so we're going to use from the left, so we're going to use 2x plus 3. Limit as h approaches 0 from the negative of 1 plus h plus 3 minus, once again, it's 7 over h equals the limit as h approaches 0 from the negative of 2 plus 2h plus 3 minus 7 over h, which is equal to limit as h approaches 0 from the negative of 2h minus 2 over h. Okay, so once again, we can't easily get rid of this h. Oh, sorry, thank you. There we go. Once again, we can't easily get rid of this h. So what we're going to do is we're going to look at it. If we were to sub in this here, this would be a negative minus 2. So the top is definitely negative. The bottom is also going to be negative because its value is less than 0. So the negative over negative means it's positive, and this will be infinity. So not only are these limits not defined because they're infinities, also they're not equal. So it's not even like if it was still, but even if it was still both positive infinity, it's still not defined. So we would say the derivative at x equals 1 does not exist or is undefined. I will freeze that, throw up the last question. So we have d of x is equal to x squared plus 4, 2x plus 3, x is greater than 1, x is less than or equal to 1. Okay, are there any questions about the last example now before I'm just going to go right into the solution for this one? Yeah. Hey guys, can you both speak up and then everyone else speak lower? Mm-hmm. Mm-hmm. Right. So we know it's discontinuous by the definition here and our visual here. And we know since it's discontinuous, this is not going to be defined. But we're saying, let's say we didn't see that. Let's say we didn't notice that. What would our functions actually do? And we find that we get, because the tangent is basically, okay, it's like the secant is from here to here. And then the secant is from here to here. And then it's from here to here. And then it's from like here to here. So it's a directly vertical line. So that's why we're getting infinities. So the secant line is the line between 2 points. So if we were to have our secant line here, this would be the slope if we went from this point to this point. And our tangent line is the limit as the secant line is only the line at 1 point, right? So it would be here with this point and this point. And then it would be here with these 2 points. And then as we get to 0, you get a vertical line because it's trying to go from this function here to this point here, which is off the line, off the curve, sorry. Yeah, and so it's not defined, but if we were to calculate this limit, it gets negative infinity. Yeah. So there is no tangent line there. But we're saying by this equation, we would get negative infinity, but there isn't a tangent line. It's not because of the fact that it's not differentiable at that point. Yeah. Cool. Question? No. Okay. Let's go through this one. This one will actually work, so that'll be fun. Okay. So let's just get right into it. So if we have d prime at 1 is equal to the limit as h approaches 0 from the positive of d1 plus h minus d1 over h is equal to the limit as h approaches 0 from the positive. We're coming from the positive, so it's going to be 1 plus h squared plus 4 minus, if we sub in 1 here, we're defined, we get 5 minus 5 over h equals the limit as h approaches 0 from the positive of 1 plus 2h plus h squared plus 4 minus 5 all over h. The constants cancel each other out. 1 plus 4 is 5, minus 5 is 0. So we get the limit as h approaches 0 from the positive of h squared plus 2h all over h. We cancel out those h's. So gone, gone, gone. And we sub in 0. So we get 0 plus 2, which equals 2. So the slope coming from the right is 2. And now from the other side, so d prime at 1 equals the limit as h approaches 0 from the negative of d1 plus h minus d1 all over h equals the limit as h approaches 0 from the negative. Since we're coming from the left, we're going to use this function. So it's 2, 1 plus h plus 3 minus 5 once again, all over h equals the limit as h approaches 0 from the negative of 2 plus 2h plus 3 minus 5 all over h. Constants all cancel each other out again. 2 plus 3 is 5 minus 5 is 0 equals the limit as h approaches 0 from the negative of 2h over h. The h's cancel each other out. If we sub in 0 to nothing, we just get what we had. So this was equal to 2. So therefore, the left and right limits are equal. And finally, we can say that d prime at 1 is equal to 2. There we go. Okay, so if you have questions, just come up here. Once I'm packed up, we're going to go outside together. I'll answer them because there will be someone else coming in here afterwards. And other than that, have a great day, everyone, and enjoy your weekend. Pardon? And what did I say?